Hello, in today's lesson, we are going to see more applications in vectors by using dot and the cross product. So the first topic we want to cover is the projection of the one vector onto another vector. What it means is similar with our work. So if we have a vector u and we have another vector v, we want to find the projection. It means like the shadow. So just draw a perpendicular line, and this part we call projection of the vector u on vector v. So this is like if we have a flashlight, then you will see the u will block the flashlight, and here is a shadow. Okay, so it's kind of like if we put a flashlight here in a dark room, flashlight, then here we got light, but here this line will block the light and leave a shadow here. This one is a projection of the u vector on the v vector. And the difference from the work is here is just a force. The force on the v direction. So it's not a work. Work is F times the v. So the work equals F times dot v, and the shadow is F on the v direction. Okay, if it's x direction, it's just we find the x component. So this is a projection definition. So it's written in this way. So project the vector u onto v bracket equals u dot v is our work before, and we know that is not the work. It's need to divide it by the magnitude of v. We only need the unit vector of the v. So the unit vector is v over magnitude. So this work then divided by the magnitude of the v. This is a scalar. This is a magnitude of this projection, and after that we times the unit vector. Unit vector on the v direction is v height. V height equals v vector divided by the magnitude of v. We put them together, then you will have this one. U dot v, then divide by v magnitude squared, then times v direction. So this is a formula you have to memorize. And the magnitude. The magnitude is just this part. It's just u dot v. Actually, this is a scalar already. We put it in the absolute value. It's just we want a positive number, then over the magnitude of the v only, because this part is a unit vector. So now we are going to use this projection formula to find out the projection of u onto the v. So we copy this formula here. So projection of u onto v. Then we have u dot v over the, because only projection, we don't need the v value there. It's just the final magnitude will be about u instead of the v. So we times v direction all over v magnitude. So from here, we want to, from given information, find u dot v equals what? So the dot product is just x direction times y direction times and z direction times. So it will be u1 v1. The v1 is 1 just x direction, u2 v2 plus u3 v3. Then we sub in the numbers. It's 5 times 1 plus 6 times 4. Then plus -3 times 5. Get your calculator out. We are going to find out is 14. And the magnitude of v squared. So we know the magnitude is a square root x squared, v1 squared, v2 squared, plus v3 squared. And this is a magnitude. Now it's squared, so it just square roots and squared cancel out. We only have the v1, v2, v3 squared add together. So 1 squared plus 4 squared plus 5 squared. And we find out it is 42. So now we have u dot v, we have v magnitude squared. We just sub in all this one into the projection of u onto v equals u dot v is 14 and magnitude squared is 42, then times vector 1, 4, 5. So we simplify it. We have 1 over 3 times 1, 4, 5. We could move it to inside the bracket 1 over 3, 4 over 3, and 5 over 3. So you will see that the projection of u onto v is a vector. The final answer is a vector. And if we want to find the magnitude, we just ignore this v direction. We just put this one at the square root. So now it didn't ask you, but if you want to find the magnitude, it will be just u dot v is 14, and the magnitude not squared is just square root. This one is square root 42. And if we want to write it as a rational, we just rationalize it. This is one term. We just times this term to both top and bottom. Then the denominator, we are not going to have square root radical sign. So square root squared is itself 42. Then square root 42, we simplify. We are going to have 1 over 3, then square root 42. So this is magnitude. This example 1 didn't ask you the magnitude. I just want to show you. Yeah, if find the magnitude, it's just don't have to times the vector v. We just need to square root the magnitude. Then we have the projection magnitude. The application of projection on the vector, one application is a work, okay, to find the force that is a useful force. The vertical one won't contribute to the work. It's a useless force. And also it could be used in video game design, and also could be used in statistics. So, and next one, so this is our work. It's f dot d, it's fd, then cosine theta. If sine theta is a cross product. So this is what we have done before, okay? And example 2, this is an application for work. Mariana is putting her daughter in a toboggan and is exerting a force of 40 Newton acting at 24 degrees to the ground. if Mariana pulls the child a distance of 100 meters, how much work was done? So we are going to draw a free body diagram. So we treat the ground as a horizontal x direction, and the vertical positive up is y positive direction. So the force is 40 Newton, and the angle formed with ground is 24 degrees. So we know that the force is going to be the F projection on the moving direction. That is force contribute to the work. So the work is a dot product F dot displacement, and in this one it was given the F and D, the magnitude was given, so we could use magnitude times magnitude, then cosine angle between the two vectors. So you may wonder when we are going to pick this one, when we are going to just use a dot product. When the vectors are given in component vectors like coordinates, then we just use a dot product right away. If it's given the magnitude of each vector and the angle is given, then we are going to use this magnitude times cosine angle. So it's 40 times 100 and times cosine 24 degrees. So it will be 3654.18 joules. And because the given information no decimals, we just could round it to no decimals. Then write the statement. The work done was 3654 joules. Okay. So this is a application in work, and the next one we are going to see more applications. Actually, we have done this before too. This application is area of a parallelogram. If you have u and v as sides, then the area is just a cross product. If we have two sides as a parallelogram, one is u, another one is v. If it's given in the component vectors form, then the area of this parallelogram is easier to find. It's just u cross product v. And magnitude, because we know cross product give us a vector. So you put your hands and wrap your finger from u to v. Your thumb direction is a direction of the cross product. So this one we have ABC, a triangle. So instead of parallelogram, we have ABC. Okay. And you will see, in order to find the area, we could just find two sides, any two sides. You could find ABBC or ACBC. They will give you the same area. So we are going to see. We want to find the side, each side, at least two sides of the triangle. So side AB, before we know that is from OB minus OA will give us AB. So OB is 620, OA is negative 314. Then subtract 6 minus negative 3 give us 9. 2 minus 1 give us 1. 0 minus 4, negative 4. This is one side, and we find another side, AB, then AC. And here, be careful. We need to stay with one vertex. So if AB, then another one is AC. These are the adjacent vectors. So this one will be OC minus OA. Always a second letter minus a first letter. So OC is 3, negative 1, 1, minus negative 3, 1, 4. If you have trouble with this one, you can go back to see the notes, or I could just draw it. So this is point A, this is point C. And if we put it in the XY coordinate, so this is OA, this is OC, then you will see that OA, AC, OC, OA plus AC, head, tail, head, give us a resultant OC. That's the reason AC you just move to other side. It's OC minus OA. So it is true. The second letter OC minus the first letter OA. Then this one, 3 minus negative 3 give us 6. Negative 1 minus 1, negative 2. 1 minus 4 is negative 3. Then step 2, we just need to use a definition for the area equals these two cross product. And if we put magnitude there, it doesn't matter the order. Otherwise, if you switch the two vectors, the direction will switch. Because if you put your finger wrap from AC to AB, then your thumb will be put inside, point inside. If from AB to AC you wrap your finger, your thumb will be pointing outside of the page. So this one, we are going to cross product. We are going to draw the matrix. So IJK. And AB is 9, 1, negative 4. And AC is 6, negative 2, negative 3. For the I direction, it will be just this part to find the magnitude of this 2 by 2 matrix. So we are going to do the calculation. 1 times negative 3 minus negative 2 times negative 4 give us negative 11. So I will just write it a little bit quickly. So this cross product gave us negative 11. And for the J direction, we move the IJK to the back. So J direction is just this part. Negative 4 times 6 minus negative 3 times 9 give us 3. And the K direction is just the first two. 9 times negative 2 minus 1 times 6 give us negative 24. So this is a cross product, but we want to find the magnitude. It will be equals square root x squared, y squared, z squared, I together. So it will be negative 11 squared plus 3 squared plus negative 24 bracket squared. And here, be careful, this is a triangle, so we have to half of the parallelogram area. So we have 1 over 2 at front. Then we do the calculation for and the square root is 706. Then approximately 13.29. So this is area of a triangle, and you will see, use the cross product, it will be a little bit easier for us to find the area right away instead of using the triangle. So we have the three sides, then we have to find the angle here, then after the angle here we use a opposite over hypotenuse or equal sign to find this height. After that, 1 or 2 height times base get area. So more steps to use trigonometry, and the cross product is a little bit more organized, neat. Okay, and another application for cross product is torque. Okay, so next one is the torque, and the torque is describe the turning effect, how powerful the turning force applied. So the force about a point, the point we call is pivot point. And for example, if it's a nut, and we use a wrench to turn it, so here is a level arm of a wrench and a force we applied here. So the R is just a distance from that pivot point to the force applied. And the force is, the angle is described the angle formed between the distance from that point and the vector with a force applied. So this is a angle theta, and the cross product we know that is R times F times this sine angle. And we know that the torque cross product, this one is if it's the cross product is a vector, so the direction we use n to represent it. How to determine the direction of n? If we use a right hand rule, you just from R to F, you just extend it a little bit. So this is R direction, then you turn. You use your right hand, wrap your fingers. So from R to F, your thumb is pointing outside of the paper. So we use a dot to represent its outside of the paper. So R to F is this direction. Okay. And if FR will, if it's from F to R, we are going to put this one F to R, wrapping your hands from F to R, then the thumb will point in the inside. So it will be, if inside, we use a cross to represent the direction of the cross product. But this one is R first, okay? So R is F is applied force, and R is a vector determined by the lever arm acting from the axis of the rotation, pivot point. Angle is between the force and the lever arm. The N is a unit vector perpendicular to both force and R. Torque is a vector quantity, the unit is in joule. So, example 4. A 20 Newton force is applied at end of a wrench that is 40 centimeter in length. So we could change it to meter. So 0.4 meter, because it's divided by 100 centimeter. That is 1 meter. Okay, it's kind of times 40 centimeter times 1 meter over 100 centimeter is 1 centimeter. Centimeter cancel out. Then we have 0.4 meter, unit conversion. The force is applied at angle of 60 degrees. with a lever arm. Okay, it asks you to calculate the magnitude of the torque about the point of rotation. Okay, and this one we know that the magnitude of F, magnitude of the R given, and the angle between the two given, so we could write use a graph. Given is magnitude of force, magnitude of the R, and angle between these two. So required to find is a torque, and analysis is torque equals cross product of R cross F, and in the magnitude is FR, then sine angle theta times the direction. So this one only asks for magnitude, it's just this part. So magnitude is just equals FR magnitude times sine angle theta. F is 20 times 0.4 times sine 60 degrees. Use your calculator, is around 6.92 joule. We could just round it to one decimal place. Then write a statement, therefore the magnitude of the torque is 6.9 joules. So this is all for today's lesson. What we have done is the application of dot product and cross product. So dot product is just x direction times y direction times z direction times and I together. That is a dot product. And projection is just u dot v then times v vector over v magnitude squared. This is a formulas you need to memorize. And the work, we have done it before. Then the area is just cross product for parallelogram. For triangle is just half. And a vector of AB, we could use the second letter OB minus the first letter OA. Okay. Then we could use a matrix to find the cross product. And the torque formula is just magnitude R times magnitude F times sine angle theta. So thanks for watching.